Alright, ladies and gentlemen, this is your captain speaking. I am back for another day of fun and relaxation up here at about 10,000 feet. This is Algebra 2, Topic 3, Systems of Linear Equations Assessment. Says, show all of your work on this paper. Work should be complete, neat, and organized. Yeah, you'll find my work complete. It's mostly neat, and it's as organized as my brain can handle it. So, here we go. A student has 12 coins in her pocket that has a value of $5. The coins are either nickels or dimes, and write and solve a system of linear equations that represents this scenario. So here we go. We got nickels. I'll use N for nickels and D for dimes. Okay? Why make it X and Y so I have to remember what they are? The first thing, she has a total of 12 coins. So if I just say, hey, the nickels plus the dimes, well, that'll equal 12 coins. Woo-wee! The other one is a grocery list. Basically, it's like the cost of the bread plus the cost of the cost of bread times how many you buy, the cost of the milk times how many you buy equals your total. The same idea here. The cost of a nickel is 5 cents times the number of nickels I got, plus the cost of a dime is 10 cents times the number of dimes I've got, and that should equal a total of $1.05, $1.05. And there are your two equations. All right. From here, I'm going to multiply. I'll use elimination. Why not? I like elimination. So I'm going to multiply all these by, let's do negative 0.1. Cool. So this is now a negative 0.1 n minus 0.1 d equals negative 1.2. Cool. Let's add them up. 0.05 minus 0.1 is negative 0.05 n. Those guys go away, equals $1.05 minus 1.2 should be negative 0.15. Negative 0.15. So yay, I've got that equation. I'll just clean it up real quick. Negative 0.05 n equals negative 0.15. Alright, and then divide it out. Divide them both out. N equals 3. So you have 3 nickels. How nice. Well, the nice thing about that is if I have 3 nickels, 3 plus what equals 12? Well, if you have 3 of one thing and 12 total, you have 9 of the other. So I've got 3 nickels and 12, no, not 12, 9 dimes. And if you want to check yourself, yes, 9 plus 3 is 12 coins. If I have 90 cents plus an extra 15 cents, that's a total of $1.05. So we double checked ourselves, we're good to go. The answer seems reasonable. Cool. Next.
X plus.
Alright, here we go. So a classmate graphed the system of linear inequalities incorrectly as shown. Describe his mistake and tell him how to correct his work. So, he did it wrong. Bad classmate, bad. No, it's okay. He did it wrong. We gotta fix him. So first things first, let's solve for y on both of these. One of them is x minus y less than or equal to negative 2. I'll move the negative 2 over there and the negative y over there. So that is x plus 2 is less than or equal to y. Alright, and if you want to flip it around so it's in y equals mx plus b form, that's y is greater than or equal to x plus 2. Alright, there's the one equation. Let's do the other one. The other one is x plus y greater than negative 1, less than negative 1. So move the x to the other side. X is less than negative x minus 1. Boop. There we go. From here, let's graph these suckers. This is a y-intercept of 1, or a y-intercept of 2, sorry. That's a little table. So that's 0, 2. And let's just pick a point right here. Let's pick 2. 2 plus 2 is 4. So that one should be at 0, 2, 2, 4. 2, 4. And it's an equal to and it's solid. Yay! And it's a greater than. Oh, she said the classmate shaded the wrong side. They should have shaded this side. Just give it a light. No, really hard to do that, but she should have shaded this side of the graph. Alright, so that's the first thing. This side should not have been shaded. Let's go over here, see if this one's done too. If I've got x is less than negative x minus 1, again, pick an x and y. I'll do this one in orange. X, y. If x is 0, 0 minus 1 is negative 1. If x is, let's say, 2, negative 2 minus 1 is negative 3. So that's 0, -1 right there, and 2, -3. Good. Well, we at least got the line right, and that's dash. And it's less than, so it should be shaded here as well. Oh, good. So she shaded that. The only thing she did wrong is she shaded the green one on the wrong side. So it's kind of like, if I were to do that, it'd be this side, and it'd be this side, which I know that's a big mess. But bottom line is this. Instead of having this area down here as your overlapping region, this area right here should have been the overlapping region. Yeah, fill it in really good. Don't leave any spots open. Remember, you got to stay within the lines. Color the whole thing in. Yeah, there you go. 1, 2, 3. Good enough. Alright, cool. Let's move on. Solve the system by substitution or elimination. Okay. I'm going to use elimination. Why? Because I can multiply this by -4. And the x's cancel out. So that would be -4x. That would be a +8y. And that would be a 0. Those go away. 8 minus 3 is 5. 15 plus 0 is still 15. And 15 divided by 5 is 3. So y is 3. And if y is 3, let's plug that in. X minus 2 times 3 equals 0. 2 times 3 is 6. Move it to the other side, so x equals 6. Cool. So your answer is 6, 3. Alright, let's keep rolling. Dink. Alright, which graph shows the system of linear inequations? Justify your answer. Okay, first things first, let's solve for x. Let's solve for y. So let's do this one real quick. The one on the bottom. Yay. Move that over there. X equals, I'm sorry, not x. Y equals -x minus 2. Yeah, that was hard. Let's do the other one. Let's go over here. 6x minus 2y equals -4. Subtract 6x. 2y equals -6x minus 4. Divide by -2. Y equals -3x. Nope, not -3x. Positive 3x plus 2. Alright, and just to get ourselves some points, if x is 0, y is 2. If x is, let's just say 2. How much room is on these? No, it's very short, so let's do x is 1. 1 times 3 is 3, plus 2 is 5. So there's that one. This one, x, y. When x is 0, y is -2. When x is 1, that's -1, minus 2 is -3. So, those should be the points that we should see. So, 0, 2. Ding. Come on. 0, 2. 1, 5. Nope, not on the board. 0, 2. 1, 5. Oop, that one's on the board. Check. The other one is 0, -2. 1, -3. Yay! Those are the other 2 points. So we stumbled across it initially. Check. Those should be the 2 lines you get. This one has this guy, but not the other one. This one doesn't have either of them. Okay? Yeah. That's just it. So the answer is, put a big old box around it, B. Carlos made phone calls to Canada, the United States, and Mexico. The phone charges were 28 cents per minute to Canada, 30 cents per minute to the U.S., and 84 cents to Mexico. It cost a fortune to cost Mexico. What's up with that? His total bill for the month of December was $90.96. He talked twice as long to Mexico as he did to the United States. The total of minutes he spent talking to Canada and Mexico was 112. Write a system that can be used to determine how many minutes Carlos spent on the phone to Canada, United States, and Mexico. Do not solve. Well, the first thing, when it says do not solve, what we are definitely not going to do is solve. Okay? Because that means it might be, let's just say it maybe a massive pain in the butt, and it's not worth our time. But, so we just got to build it up. So we've got 3 equations. We have 1, total, we have one grocery list, and we have one comparison. First things first, I'm going to call this, we're going to say C equals blame Canada, blame Canada. We're going to say the U equals America. We'll put an exclamation point. Make it kind of French. No, it doesn't need that. And we'll say M is our brothers and sisters to the south, El Mexico, Mexico. Authors of the wonderful Tex-Mex food. Not really. I know better. But whatever. Let's start making equations. So first things first, there was a total of 122 minutes. But total was 122 minutes. That was the total. So, well, if I just do... No, not the total of all of them. The total of just Canada and Mexico. So if I do Canada plus Mexico, I will get 122 minutes. Oh, there's the first equation. What else? He talked twice as long to Mexico as he did to the United States. Ooh, that's our comparison. He talked... Let me see if I can underline that. Where is it? Just lost it. He talked twice as much long to Mexico than he did to the United States. So what I'm going to do is I'm going to say Mexico equals the United States. All right, and we got to multiply one of them by 2. Now it says he took twice as long as Mexico. So Mexico is twice the size of the U.S. So in order to make them equal, I have to multiply the U.S. by 2. Okay, if that's freaking you out, think of it this way. Mexico is twice the size of the U.S. Right? Mexico is twice as much as the U.S. So in order to make these equal, I have to multiply that one by 2 to make them equal. You follow? That's why we had those ones. The comparison ones always feel a little bit backwards, at least the way I think through them. Miss Hunter may have a better idea, but that's how I think about it. The phone charges were 28% per minute to Canada. Okay, here's your grocery list. 28 cents a minute to Canada, 0.28 times Canada, plus 30 cents a minute to the U.S., 0.30 to the U.S., plus 84 cents a minute to Mexico. Makes me worry, where is he equal a total of $90.96. There's his grocery list. Where grocery lists are just the amount times how many, plus the amount times how many, plus the amount times how many. Like you went to the grocery store. Cool? And that's that. So here we go. Graph the system of constraints, name all the vertices, then find the values of x and y that maximize the objective function. So, ooh, Miss Hunter didn't even give us an axis. That's fine. Looks like everything's positive or 0. So we're going to do quadrant 1. I'm just going to do this. And everything is less than 10. So we're just going to make this 0, 0. Oh, I see what's going on. So y is greater than 0. So that's one axis. Y is less than 2. Well, that's easy. That's this axis. So it's between those two. X is greater than 0, so that's greater than this vertical right here. And x is less than 6, so 6. Can I count? 1, 2, 3, 4, 5, 6. Good. So it's less than that, but greater than that. So it looks like everything is within this box. So we got our 4 points. Let's label these real quick. So this is 0, 0, 0, 2, 6, 2, and 6, 0. So those are the points we're going to plug in to our formula and see which one is the biggest. Because they want to maximize. If they wanted to minimize, we'd look for the smallest. So here we go. We're going to look for P of 0, 0, which equals 3 times 0, minus 2 times 0, which anything times 0 is 0. 0 minus 0 is 0, 0. Alright? P of 2, 0. 3 times 2 is 6. Minus 2 times 0 is still 6, so that's 6. Let's do P of Why did I do 2, 0? I have no idea. Let's back up a little bit. Let's try that again. Ignore what I just said. Let's try this again. Hopefully you're not writing in ink. That's why you should never do math in ink. 0, 2. Okay, so 3 times 0 minus 2 times 2 is 4. Not negative 6. Let's erase that too. 0 minus 4 equals negative 4. I'm pretty sure that doesn't maximize your profits because it's not. It's less than 0. Next one, profit is, let's do 6, 0, that bottom right corner. 3 times 6 is 18, minus 2 times 2, which is 0, that's 18 minus 0 is 18. That's probably the candidate right there, but let's do the last one. Probability of 6, 2 equals 3 times 6, which is 18, minus 2 times 2, which is 4. 18 minus 4 is 16. Last I checked, 18 is bigger than 16. So, the coordinate, 6, 0. 6, 0 maximizes P. Cool? Probably mean profit by that, but that's what it is. Any questions? Ask your teacher. She won't answer you because this is how she's speaking still. What is the solution to this system? Nobody got time for that. Doesn't Miss Hunter know that? No. Okay. So I'm going to use elimination on this because this already has no z on it, and these two z's cancel each other out. So we're going to do elimination because 1 minus 1 is 0. So let's combine the x's and the z's. So 1 plus 2 is 3. Oh, this is easy. 1 plus 1 is 2, plus 2z equals 6 plus 3 is 9. This is too easy because those line up right there. So let's multiply this by negative 1 so they cancel out. So that's negative 3x plus z equals, well, negative 1 times 0 is still 0 last I checked. Add those two together, your x's cancel out. 2 plus 1 is 3z. 9 plus 0 is 9. Divide by 3, the z equals 3. Cool? Well, if z is 3, I can plug that anywhere I want. I'm going to plug it into this one right there. So if z is 3, that means 3x minus 3 equals 0. So that's 3x equals 3, which means x equals 1. Alright, and I want to use this one because it's got the fewest coefficients. Makes life even simpler. So we've got xy plus z, we've got x, which is 1, oops, x which is 1, plus y, which we don't know, plus z, which is 3, equals 6. 6 minus 3 is 3, minus 1 is 2, y equals 2. So the solution to this system has to be 1, 2, 3. And you can thank Miss Hunter for having the most original answer on the face of the planet. 1, 2, 3. Really, sweetie? Alright, anyways, whatever. If you want to check your work, just to make sure. Oh, now you say that. Alright. If you want to check your work, you can always build an augmented matrix. 1, 2, 3. 1, negative 1. Don't forget your 0 because there is no y. 1, 1, negative 1, and then 6, 3, 0. Plug that into your matrix in a 3 by 4 matrix. Then run your pirate function, your ref function. And then, yeah, you should get this 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 2, 3, which means that is your x, that is your y, funky x over there. That is your z. Cool. You double check yourself, you know you did it right. Alright, let's keep rolling. I don't have room for the next one, so let's pause. Alright, last but not least, thank you very much, ladies and gentlemen, for sticking with us so far. The snack bar cooks and sells hamburgers and hot dogs during football games. To stay in business, it must sell at least 10 burgers, but cannot cook more than 40. It must also sell 30 hot dogs, but cannot cook more than 70. Okay, so I can do 10 hamburgers, let's just put some, so 10 hamburgers, but not more than 40. And 30 hot dogs, I gotta use some other mage, don't I? Let's do D for dogs. But no more than 70. Okay. The snack bar cannot cook more than 90 items total, so we'll do 30 plus. No, 30 plus. What am I thinking of? Hamburgers plus hot dogs. Again, hamburgers plus dogs cannot be more. Must be less than or equal to 90. All right. The last one, at least, the profit on a hamburger is 33 cents. The profit on a hot dog is 21 cents. Oh, okay. So our profit function. The profit on a hamburger is 33 cents, so 0.33 times every burger plus 0.21 on every hot dog. How many of each item should the snack bar sell to maximize their profits? Okay, so let's go ahead and do this. Let's make this 0, 0, and we'll count by tens. 10, 20, 30, 40, 60, so that's 20, that's 40. We'll make this our hamburgers. We'll spell it like the Germans. Hamburger. No, B-U-R-G-H-E-R. And then we'll throw some letters on the end of it just for the fun of it. No, not really. And we'll spell the left sides like the French. So from 30 to 70 for your hot dogs. So we'll do 10, 20, 30, 40, 50, 60, 70. Good. 70, 60, 50, 40, 30, 20. And we'll spell this one like the French. Dogs. Hot dogs. We'll put an apostrophe there over dogs. That makes it French. But the hamburgers are between 10 and 40. So the hamburgers are somewhere between 10 and 40. Hot dogs are between 30 and 70. So hot dogs are between 30 and 70. So far we're somewhere in there. The other constraint is you can't have more than 90. So if I tell 10 and 70, that's okay. But if I sell 70, I can't sell more than 20 hot dogs. I can't make more than 20 hamburgers. Okay? If I make 40 hot dogs, I cannot make more than 50 hamburgers. So I also have this line going through it right there. So this is the boundary of my function. Miss Hunter gave you a fun one. It actually has 5 points to look at. We'll see which one maximizes our profits. My guess is that one, but I really don't know. So here we go. Let's start cranking them out. Let's do it in blue. We've got 5 points to choose, so we're going to pick the first point at, what do we do, 1030? 1030. The second profit we'll look at is 1070. The third profit will be at 2070. The third profit will be at 4050. The fifth profit we'll look at is, what, 4030? Yeah. That's if we make no hot dogs whatsoever. Or make the fewest amount of hot dogs possible. I'll put it that way, not no hot dogs, but the fewest we're allowed to. Alright, and then let's make these work. So that's 0.33 times 10 plus 0.21 times 30. And you know what? I will amaze you in a few minutes as to how quickly I do that. 0.33 times 10 plus 0.21 times 70. Again, I will amaze you at how quickly I can do that. It's pretty fascinating. 0.33 times 20 plus 0.21 times 70. I got 0.33 times 40 plus 0.21, lost my train of thought, times 50. How many more of these we got? Oh, one more. Okay, good. 0.33 times 40 plus 0.33 times, not 50, 30, right? Alright, now it's time to amaze you with how quickly I can compute and write every last one of these. You ready? Ta-da! I told you I was fast. So here we go. You got all those up there, and we said that this one is the biggest, which is this point right here. That one will maximize your profit. So we'll say 40, not 4 little zero, 40 hamburgers. And what, 50 hot dogs? 50 hot dogs will maximize your profits. Ding!